Okay, first question here should be pretty straightforward. It's really a friction question. So if I read it, I'm going to do shortcuts for you guys, sorry. This is the mass of a box sitting on the floor. We're given two coefficients of friction. We've got static coefficient here, and we've got a kinetic coefficient here. We're going to have to decide, hey, is this box already in motion? So we've got kinetic friction, or is it just about to move or not moving at all? If you look here, we've got to start the box moving. It's the to start that's the key. To start is going to tell us that we're looking at the coefficient of static friction. So what do we know? How do we relate these variables? Well, we know that we can find a frictional force by looking at the coefficient of friction, in this case static, as we just decided, multiplied against the normal force. Okay, I don't see normal force in the question, but I do see mass. You may or should recall that normal force is equal in magnitude but opposite in direction of the force of gravity. Now this is something we can use because we can get the magnitude, drop it into this formula, figure out the frictional force. That'll relate back to our question. So let's start by finding the force of gravity. This one should be a calculation you're very familiar with. We do it often, right? This is mass multiplied by the acceleration due to gravity. I know we're on Earth. Well, it's implied that we're on Earth. So I put in a mass of 20, and I multiply that against 9.81 to find an answer for what my force of gravity is. And then I'm going to use that, because it's equal in magnitude, to my normal force. Okay? So then I'm going to have, well, what is the frictional force? If I use, well, I've already said it's static, so it's going to be 0.45, and then I'm going to multiply whatever the answer is here. So I'm going to pause the recording, do my math, come right back. So according to my calculator on my phone, I've got 196 newtons of normal force to contend with. I'm going to multiply that by 0.45, and I should find out that my maximum frictional force, static friction force, is 88.29. If I want to get this box to move, I've got to push with a minimum force equal to or greater than this amount. So now I'm going to check significant digits. Look like I only have two of them. You can see here and here. Well, I didn't use that one, I'm sorry. So I've got to change this answer to actually be just two significant digits. So I'll round that to 88 newtons of force required to get this box going.